Now we're really going to start to expand some of these compound statements and the truth tables for them. I've got a couple statements here. Again, we'll go back to I visited Big Bend National Park and I visited Carlsbad Caverns National Park as my two statements. I never really said whether they were true or false. Actually, they are true. I gave it away finally, but it doesn't matter whether they're true or false. We want to get all of the possible options out there. It will eventually matter whether they're true or false, but for the truth table, it doesn't. In fact, we're going to assume it could be true or it could be false for each one, and then kind of work our way through. So usually with these truth tables, we start sort of basic and then build up more and more complicated expressions. I've just got a list of some things up here, and I was kind of making these up as I went. There isn't a particular order in which you might do these. I'm just throwing some more complicated ones out here towards the end, just to practice with. Okay, and so in this case, P and Q. Again, P and Q can either be true or false each, and so we have 2 to the n options, right? 2 to the n rows where there's 2, our n is 2 because that's the number of simple statements, and so 2 to the n is 4, right? 2 to the 2 power, so there's going to be 4 rows, and when I start to set these truth tables up, my first simple statement, I usually have half of the number of rows are true, half the number of rows are false. So I do 2 trues and 2 false. Okay. Then I go to the Q, and then Q, I just have to alternate. I have to make sure that there's a true and a false with each of the other options. So I go true, false, false. Then everything else from there is dependent upon the first 2 columns. Remember, negations are always the opposite. So the negation of a true is false, and the negation of a false is true. So not P would be false, false, true, true. It's the opposite of P. Not Q, or the negation of Q would be false, true, false, and true, right? It's the opposite of whatever Q is. Now we have a conjunction, an and, right? And remember, ands are only true when the 2 simple statements are both true, okay? Well, here, my simple statements is not just P and Q, it's actually not P and Q, right? The not goes with P, so it's the not P and Q. So it's these 2 columns I'm picking for the conjunction. And so what I need is both of them to be true in order for the conjunction to be true. So if I go down these 2 columns, they're both true in the 3rd row, which means that 3rd row for the conjunction is true. And for a conjunction, since that's the only row that can be true, everything else is false. As long as one of the options is false, then the whole statement is false for a conjunction, for an and. Because it has to be the case that both not P and Q are true. So I'd have false for the other 3 rows, okay? Here I have a disjunction, an or. It's P or not Q. So I look at the P column and the Q not Q column, sorry. And for a disjunction, remember, disjunctions are only false when both simple statements are false. Everything else will be true. As long as one is true, they're both true. One or both. So I go to the P and the not Q, and I look for both of them being false, and I identify it right here on the 3rd row again. And so that is the only false, the only time when the disjunction is false. The rest of them will be true. So I can go true, true, true. Okay. Then the next one I have, and each of these is independent. I am kind of building these up, but I don't have a particular rhyme or reason as to why I chose these. I just was picking some random things off from prior columns. So here I have the negation of P or not Q. Well, I already have P or not Q in a prior column. So all I have to do is take its negation, right? So it's the negation of that column. So it's going to be the opposite of each of these three, or each of these four T's and F's. So we're going to have F, F, T, F. Okay, it's the negation of that column. Now finally, on the end here, I have a disjunction with a conjunction as the first statement and a negation as the second statement. And so what I need to do, both of these have their own column already. So we always build these up. If I had a statement in mind, I would build up the truth table in such a way that the parts would kind of develop out. We'll do an example in the next video where we do something more complicated like that. We have a kind of a goal in mind. So here, I would take the not P and Q, which we already have a column for, and I would also take the not Q, which I also have a column for, and I'm looking for this as a disjunction, an OR, which means the only place it's false, the only place it's false is where both columns here are going to be false, which occurs out of these two columns in the first row, right? They're both false there. So a disjunction is false where both simple statements or simpler statements are false, okay? Everything else is true. If you have one of them that's true, then the whole statement is true. If you have both of them, actually in no place is both of them true, but one is true, one is true, one is true. So as long as one of them is true, then you will have a true disjunction. All right, so it'll be true, 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 all the way down. Okay. All right, so now you can kind of see how we build these tables, at least how we build columns off of prior columns. In the next video, we'll start with a complicated statement and we'll try to build the table from scratch, kind of working our way, building up the little pieces until you get to the final complex statement.